Hello everyone, this is Steve. We're going to graph this rational function together. This is probably actually the most difficult one of the videos I'm making, so let's go ahead and get started. I'm going to factor both the numerator and the denominator to make it easier to find both the x-intercepts and the domain. So if I factor the numerator, the first thing I do is pull out a 3, greatest common factor, and then the rest of it factors as x minus 2, x plus 1. The denominator is actually a perfect square trinomial, so it factors as x plus 4, or x plus 4 quantity squared. Either way is correct, however you want to write the bottom. Okay, let's find our domain. There's only one number to kick out because there's only one number that makes the denominator equal to 0, and that's negative 4. And because there's only one number getting kicked out of our domain and no factors cancel, factors won't cancel in Math 121, we also get one vertical asymptote, which is x equals negative 4. Got to write that as an equation, not just a number. Horizontal asymptote, you bet we have one of those, because if you look at the original function, it's a little easier before you factor it, you can see that we have a degree 2 and a degree 2. And if the degrees match, then you find your horizontal asymptote by dividing the leading coefficient of the top, 3, by the leading coefficient of the bottom, 1. So we divide 3 by 1, and we get 3. So our horizontal asymptote is y equals 3. X-intercept, these are easy to find because I already factored the top. So our x-intercepts are going to be 2, 0, and negative 1, 0. And they both have a multiplicity of 1, so we're going to cross at both of them. No bouncing. Do we have a y-intercept? As long as we didn't kick y out of the original domain, we have a y-intercept. The only number we kicked out was negative 4, so we plug a 0 into the function to get the y-intercept. Plug in a 0. Everything on top cancels except for the negative 6. Everything on the bottom cancels except for the 16. And we will end up with negative 3/8. So our y-intercept is 0, negative 3/8. We have our intercepts, we have our asymptotes, we are ready to go to a graph. Let's see how we do. Okay, this graph is going to have two pieces because we have one vertical asymptote at x equals negative 4. So we're going to have one piece on each side of that vertical asymptote. We also have a horizontal asymptote of y equals 3 right here. Okay, and I have a couple ordered pairs. I have, let's see here, I have 2, 0, and I have negative 1, 0. And we also have the y-intercept, which is right here at 0, negative 3/8. Now, since both of these are going to be crosses at the x-intercepts, and I need to go through the y-intercept, part of my graph is going to look like this. And then at both of those x-intercepts, I cross over the axis. So in order to hug the asymptote, I'm going to come up here like this. And it is actually okay to cross a horizontal asymptote. It's not like a vertical asymptote. So you actually can cross right over this horizontal asymptote right here without breaking any rules. That's okay. That right there, everyone, is actually the ordered pair negative 2, 3. And I'll show you how I found that at the very end of this video. The other piece of the graph that's over on the left side of the vertical asymptote either has to be down here or up here. Can't be both, because if it was both, then it would fail the vertical line test. It also can't be the one down below, because it has an illegal x-intercept. So it has to be up here, like this. And that is going to be what our graph looks like. It actually wasn't so bad. A little bit fishy with the two x-intercepts and crossing over and going below the x-axis, but this is what the graph looks like. Let's verify that with some technology. Looks pretty good to me. You can see the asymptotes just like we drew them. You can see the curve where we drew it. You can even see this feature down here where we crossed the x-axis once to get down to the y-intercept, then went back up to get close to the horizontal asymptote. So I'd say we do a pretty good graph here. The only question you might still have is what about that ordered pair negative 2, 3 that's right on top of the horizontal asymptote? So I'm going to talk about that, and then we'll leave this one behind. So I've said before that a rational function can cross or touch its horizontal asymptote, like it does in this problem at negative 2, 3. But the way you know a rational function crosses or touches this horizontal asymptote is you set the entire rational function equation equal to the horizontal asymptote value. Or in this case, you set this whole equation equal to 3. Then you solve for x. We do that by multiplying both sides by that denominator, x squared plus 8x plus 16. So if you multiply that by that denominator, we're going to get 3x squared minus 3x minus 6 over here. The 3 over here will distribute, giving me 3x squared plus 24x plus 48. Then we do a little bit of cleanup, subtract 3x from both sides. Those go away. Then we will add 6 to both sides, and we will subtract 24x from both sides. That will give me negative 27x equals 54. If you divide both sides by negative 27, you get negative 2. So in other words, when we set y equal to 3, we got an x value of negative 2, giving us the ordered pair negative 2, 3, which is an ordered pair on the graph and specifically an ordered pair that is directly on the horizontal asymptote. All right, that was a tricky one, I know. Hope the video helped. Thanks for watching.